Hi, everybody. My name is Lama. Uh, and I'll start my presentation about traveling in MDX. And when you see an MDX formula, I'm sure I'm not alone when looking at something like this. I feel this blurry feeling of being lost in an MDX. But don't worry, it's so with any scripting language, it can happen with any programming language. Everybody has been there when looking at code and not understanding where they are. But there are ways to see where you have traveled in multidimensional cube, and this is what I would like to show you today. Uh, I have been working in EasyBI support for some time, and I will share some steps that I have learned along the way of how to deal with the tough MDX calculations. So unfortunately, I can't share with you some hidden magic tool that we use for MDX debugging because there is none. What you have is the knowledge of data and some steps you can take. So what I want to share today is that you need to know your MDX building blocks and your cube and data. There are some functions that can be used for testing. And then I will share some steps to take the measure apart and put it back together again. But first, I want to start with a little story that is a story from true life, from my university times. When we were traveling around Europe with a group of friends, we went down to Greece and back again. And one of our stops was supposed to be split in Croatia. And we were supposed to enter there from Bosnia, somewhere around here. We started to travel in the evening and wanted to camp in the night, already close to our destination. This was back in the times when we didn't have navigation tools, at least not available to students. So we rolled out our big maps, looked where we are, where we want to go, what road signs we need to pay attention to. And I'm sure you're kind of guessing where I'm going with this. We had some good coffee, some good conversations, and we missed some road signs. I was one of those missing them because I was sitting next to the driver. Somewhere close to the sunrise, we started to realize that we haven't looked in the map for a long time. And we entered Croatia completely not where we wanted to. There were some exchanges of words, just so you realize split is down here. We did go all the way back, but that was not the most pleasant drive back there. So who has been in this situation, feel free to share in our chat room, because I imagine everybody has some fun stories of being lost. And not always it is pleasant, but there is always a way to get out or not to get into that situation in the first place if you pay attention to the road signs. I told this story because I want to draw parallels here with navigation in the multidimensional cube. Multiple dimensions by themselves, that's a mind twist. It's really hard to visualize where you are. You don't have a map. With maybe 2 dimensions, which is an Excel type table, you can imagine where you are. And especially if you get the address of B7, you know right away where you need to look, and you can see exact data in this cell. 3 dimensions we can still imagine, but the multidimensional cube that is used in EasyBI is a mind twist, and you can't possibly visualize that. But the hardest point here is that you have to understand what you can see. When you are doing the MDX calculation, you have to know where you are, what context you have selected, and kind of understand where the MDX script is taking us. And that's some of the things that I want to share. And firstly, we'll start with the MDX building blocks, or the road signs that we have in the multidimensional cube. And the building blocks that we're talking about basically are the same building blocks that we use when we just drag and drop and create a report. Those are the same building blocks we use when we create an MDX calculation. Those are same old dimensions, measures, and properties, and you have all heard about them, and I just want to touch it briefly here. And if you haven't heard, then for sure watch the presentation from Gerda today, or go and see our training videos, because they will explain this in a lot more detail than I will now. But just to remember, dimensions we have on rows and columns, we can put many dimensions and go deeper and deeper in the data selection. And that's where this multidimensional kind of idea comes from. And then there is the important part is the measures which bind those dimensions together. So each data cell has a value, and at the same cross section, each measure will have a different value. So we have issues created in last 3 months, which gives us one number. Story points created in last 3 months gives us a different number and a different aggregation. So it's always important to know which measure you are using and in what context you are looking at it. And not all measures will always have a value. So as we look here, that a particular measure might have a value for an issue in March, while the other one, story points created, does not have any value. So you always need to make sure that that the measure actually has a value, and if not, then understand why. And lastly, of course, there are the properties, which, especially if they are numerical values, are very confusing, because it kind of shows the same thing, but it doesn't show you a total value. And that's very important, that the property is something that you see, it's an attribute that you see on individual level. So even if the property is a numerical value, you will see it only on the issue level, and there is no total for it. It's a bit easier to visualize when we are looking at the properties that are strings or dates, because then we know that we will not have a list of dates or a list of strings on a total level. But be sure that also the numeric properties you will see only on the issue level. So this is important to understand, and always make sure what you're looking at what level you are, what dimensions you are using in your calculation, what measure values you have, and are you looking at the measures or properties. And when we navigate our MDX script through the multidimensional cube, there are some basic rules that should be remembered. So first of all, you need to use the existing measures, dimension, and dimension members. You can't really invent something that is not there. You can just take whatever you have, filter it, add it, subtract it to get some new value. There are many examples and that we have in our demo account and in community, and I really highly suggest you to use them, but do that with understanding, and be careful of what you take, and in what context, from what context you have taken the measure, and in what context you are adding it. And always start simple. Probably when you copy something from demo account, start with understanding exactly what context, what dimensions were used in there, what selections, and repeat that on your data, and only then add the next level or next functions that you want to use, the next complexity. Because if you just copy and start adding something before making it work, then obviously you will end up with something that you don't know where you are, and might end up in a completely different place in the cube instead of where you want it to be. And when we talk about functions, then again, a slide that is very obvious to developers, less obvious to people who don't maybe do calculations or programming in everyday life, but the syntax is very important. So use the correct expected entry data and know what type of data you're getting out of the function. And you don't have to memorize this. The autocomplete will help you at sometimes, as well as the documentation page that we have with the function reference, and also describing the functions in more detail than the autocomplete. Just remember that all the brackets, all commas really matter. And again, there is a very good presentation by Ilse about the MDX ABC that goes into more detail about this. And lastly, about data types, when we talk in the function, of course, they also matter. And now in this slide, you can see that we have a time member on rows. And from this time member, we can get all kind of data types as an output. So each time member or each issue member, you can make a set out of it. So this is showing you the children's set of that year. Yeah, you can have a children's set of the project, which is all issues and so on. So, and from each member, you can probably also get out some dates. So here we have a starting date of the year. Issues have creation and resolution dates. Strings are the names of the members usually, or some other properties that they have. And then there is the number field that you can calculate from different available measures, or just here there is the difference, how many days are in the year, and the Boolean values, which are true or false. In this case, is it the current year or no? So the data types are very important. And as you can see, it doesn't matter what kind of member you have on the rows, you can get all kind of data types out of it. So you need to make sure what the function needs and what you're looking at. Functions for MDX testing. And yes, you are guessing it right. MDX is tested with an MDX. So there are a couple of functions that will not be used as the result in your report, but that are very useful when you are building your report. And the first one is the set to string. I put it as the first, as anyone who has ever talked to me about MDX debugging will know that set to string is my absolute favorite function. And this is because very many other MDX functions require a set as an input. And in very many cases, incorrect set that you're passing to the function is the result of unexpected, is why you are getting unexpected results. So knowing what set you're looking at and passing it into the set to string function and evaluating it will help you a lot to understand where you have traveled in the cube and what you are actually seeing. So, and when you get the result of this function, take your time and read through if you are really seeing the expected members there. You can compare them either with JQL if you know what you needed to have there, or however you know what set is the necessary one. But this is how you know what you have filtered in the EasyBI MDX and is it correct. Next one is the tuple to string, which is maybe less used, but still might come in handy, especially when the tuple is more complex than just referencing one member from each dimension. So in this case, I'm showing an example where it could come in handy when we would like to look at the open issues on a certain date. And we're getting this date with a complex query from time dimension. So in this way, we can check that the tuple is actually taking the correct date that we wanted to. So it's matching the release date that we got the member from the time dimension. So it can also come in very handy sometimes. And last but not least is the EasyBI specific all properties function, which is useful in two ways. So when we specify that we want to see all properties from a function, from a member, then we get two things out of this. We can get the exact name of the property if we want to use it in the calculation. So for example, the release date, and we know how we should type it, we can just copy it. And we do get the value of the property on each level. So two very good things come out of this that we can see and use for debugging in MDX. So now let's go to steps, how to test a calculation. So when I see something like this, don't get me wrong, I also can get very confused at first looking at a bunch of values, functions, measures, and not understand maybe where I should be starting. But the first thing that you always need to understand is what are the ingredients of the function. So I see that we are looking at a sum. The first line tells me that, and then I need to check in the documentation or in autocomplete, wherever, what does a sum function expect? So it needs a set and a numeric expression. So we can see which part of this is the set and where is our numeric expression. And now we need to take this apart to see actually what we are looking at. So what is in the set? That would be the second thing that we need to find out. And this is where the setString function comes in. What we do is we comment everything else out, and we leave the part of the function that was the set, and we put that in the setString function. And this is where we can see on what set we are seeing on which level. So if we had the effects version project level, we can see that on project level, we have all versions with the release date from that project. And we go deeper and we see which ones that the set becomes smaller for the released versions and unreleased versions. So we can see how it is grouping the versions and that we are looking actually at the set that we expected. To test the next part, we need to use, we need to put the set's lowest level on the rows so that we only have one member left. Basically, so that we are on the lowest level of the set, and we can see it either from there or in the calculated member itself. How deep are we going? So we choose the effects version level and see that we are now on the lowest level of our filtered set, and each row has one member selected. And for this member now, we can do check the numerical calculation. So we need to remember where the number started and comment that part out. So again, now we leave only the numerical part and take out the set, and we can check if the number is correct for each particular version. So first we comment it out. We see, okay, something is being returned. How do we know it's correct? So as you can see in this part, I took a quite complex function, which has a quite complex numerical expression with case, so that I can also show some ways how to test this further. So when we have a case, first thing that we want to do is make sure that the case condition is also being correct. So the first, we can check that the conditions are returning, taking us to the correct place. So is the date of the effects version in this filtered period, or is it after the filtered period? And for this, we can take out everything else in the case and just leave 1 or 10 or whatever number there, and 2 for the second case, and make sure that the case condition is actually bringing us to where we want to go. And we can see that we have a time filter, and from all properties, we can see the release date and see that the second case is bringing us, is giving us 2 when the release date is after today, or after the filtered period, which was until today, and the first is giving us 1 when the release date is in the period in the last 12 months, or until the end of April. So now we can check that actual calculation in the case is also working correctly. And here we have again a sum that takes again a set and a numeric expression. So again, we can use the set to string and see that it is returning us the correct set of time members. So everything from start date until the release date, start date of the filter period and release date. So we had last 12 months starting from June. So we can see that the first member there really is June, and we are going all the way until the release date. So again, until June 26th for that release. In this way, we can check that actually we are again looking at the correct set of time members. And what we do now, the numerical expression here was quite simple. It was just the issues created. So we can check. I'm sorry. Yeah, somehow it's not starting the video. Okay. We can check that the numerical expression is also taking the issues created and giving us the correct value in this filtered set of time. So you could also go a step further and in another tab open and filter just the period of version and see how many issues are created in this before or after release. And that would give you exact, even further making sure that this is the correct number. But I already trusted that it's giving me the correct number as I filtered the time period as I wanted. And the last step when we do the testing of the calculation is to add back all the report context that we need and make sure that all the filtering is working correctly. So what we do is that we add other calculations. We go back to the project level. And as you can see, our calculation is still showing only on lowest level because we didn't comment everything else back out and didn't leave the sum. So we need to make sure that all of our previous comments are removed and we still have the correct calculation. And then we can put it in the chart and format it as we want to. So those are the steps that we take, that we can take to check our calculation. So what I wanted to show you today is that you need to know the MDX cube and the data that you have. And there are three magical functions that you can use for testing what you see and how far you are and where you are. And what is important is that you should test your functions as you write them, not when you are already completely lost. And in that way, exploring of MDX cube will bring you much more joy and discoveries and less frustrations. So happy traveling. until the release date. So again, until June 26th for that release. In this way, we can check that actually we are again looking at the correct set of time members. And what we do now, the numerical expression here was quite simple.